Imagine a place where the laws of physics start to break down, where time stretches infinitely, and reality as we know it just ends. What happens when the universe reaches its final act? And why are scientists so divided about what comes next? The end of the universe sounds like a far-off sci-fi horror story. But for scientists studying the cosmos, this final chapter isn't just theory, it's a real mystery with pieces we're beginning to piece together. It's a race to understand what the ultimate fate of everything will be. Will the universe slowly freeze, or will it rip itself apart in a cosmic explosion? Let's dig into what happens when the universe meets its end and why things get so weird out there. For a long time, we thought we understood the universe. Stars, planets, black holes, all moving and obeying predictable rules. But as scientists have tried to understand the universe's fate, they've hit a wall. The deeper we look, the more things stop making sense. Distances stretch, time warps, and some laws of physics seem to fall apart. At the universe's end, we face something called cosmic doom. And believe it or not, scientists think it's already started. But the question is, how? And why does everything seem to go haywire when we reach this final chapter? The first clue that the universe was heading toward a bizarre ending came when scientists discovered something called dark energy. For decades, we assumed gravity would slow down the universe's expansion. After all, gravity pulls everything inward. But in the late 1990s, scientists found that the universe isn't just expanding, it's speeding up. And the cause? Dark energy. It's this invisible force pushing galaxies apart faster and faster, stretching the very fabric of space itself. Now here's where it gets strange. Dark energy doesn't act like anything we're used to. Instead of weakening as things get farther apart, it seems to stay constant or even grow stronger. Picture a balloon. As it inflates, any dot on the balloon will move further from the others. Now imagine that balloon inflating forever, faster and faster. That's our universe, and eventually, it could inflate so much that atoms themselves get pulled apart. This brings us to our first theory of the end of the universe, the Big Rip. In the Big Rip scenario, dark energy's influence keeps growing until one day, it literally rips everything apart. Galaxies, stars, planets, even atoms would be torn apart by this overwhelming force. Imagine our solar system. Over billions of years, it's held together by gravity. But with the Big Rip, dark energy grows so powerful that it overcomes gravity's hold. Planets fly off, stars disintegrate, and eventually, even atoms can't hold together. In the final moments, the universe goes from vast galaxies to nothing but isolated particles flying through space. The Big Rip is terrifying, and we're not even sure if dark energy will work like that. But here's the catch. Scientists don't know what dark energy is or why it's there. Is it a new fundamental force? Or is it something more exotic, like a hidden property of space itself? It's these unanswered questions that make predicting the end of the universe so challenging. Next up, we have the Big Freeze, also known as heat death. Unlike the Big Rip, the Big Freeze doesn't involve the universe ripping apart. Instead, it slowly and quietly fades into a kind of cosmic winter. How does it work? The answer lies in thermodynamics, the same laws that govern your car engine or how ice melts in a glass of water. As the universe expands, stars burn out, galaxies drift apart, and everything cools down. Over billions, even trillions of years, stars exhaust their fuel, leaving only cold, dim remnants behind. No new stars form, and everything becomes isolated and cold. Eventually, all energy is spread so thin that nothing moves, nothing shines, and the universe becomes an endless void of darkness and cold. Imagine the quietest, emptiest, most frozen night you've ever experienced. Then multiply that across all of space. That's the Big Freeze. Just when you think we've exhausted possibilities, here's another twist. What if the universe doesn't end at all? In the Big Crunch scenario, instead of expanding forever, the universe eventually stops, reverses, and begins to collapse in on itself. This would mean everything, from the stars to the space between them, gets pulled back together in a cosmic implosion. The Big Crunch leads us to an interesting question. Could the universe die only to be reborn? Imagine if, after collapsing into a dense point, the universe bounces back, triggering another Big Bang and starting the cycle over. Some scientists call this the Big Bounce. In this case, we'd be part of an endless cycle of expansion, collapse, and rebirth. The end wouldn't really be the end at all. With all these theories, there's one big mystery. We don't know which will happen because we don't understand what dark energy really is. Dark energy makes up about 68% of the universe, yet it's the biggest unknown in physics. Think about that. Nearly 3/4 of everything in the cosmos remains a complete mystery. Even though we can measure its effects, we have no clue what it actually is. Here's the mind bender. What if dark energy changes over time? Some theories suggest it might weaken, causing the universe to eventually stop expanding. Or what if it changes direction, and instead of pushing everything apart, it pulls it all back together? Or maybe, just maybe, dark energy itself will evolve into something we haven't even thought of yet. Right now, we're at the very edge of our understanding. Scientists are running tests, building new telescopes, and even launching satellites to help us study this mysterious force. But until we crack the code on dark energy, we're left in the dark, literally and figuratively, about the universe's fate. So here we are, staring at the end of the universe and trying to figure out what happens next. Whether it's a big rip tearing everything apart, a big freeze locking the cosmos into eternal darkness, or a big crunch followed by a cosmic rebirth, each scenario tells us just how strange and powerful the universe really is. And in the grand scheme of things, maybe that's what makes the universe so fascinating, the fact that it can surprise us even as it ends. We're in a race against time to understand these cosmic mysteries before the universe's next big twist. If you're curious to learn more about these mysteries, don't miss our next video.